Okay, question 15. So here we've got to factorise the quadratic where we don't have a 1x squared. Our coefficient of the x squared is not 1, so here it's 6. So we need to find two magic numbers which multiply make 18. That 18 comprising the 6 times the 3, so the coefficient of the x squared and the number on the end. 6 3s are 18, yet at the same time add to be the coefficient of the x, so 9. Multiply to make 18, add to be 9, and that's 3 and 6. 3 6s are 18, 3 and 6 is 9. Now our first line of workings just takes this problem from being 3 terms to 4 terms. So we've still got our 6x squared and our 3. We just break the 9x down to a 3x and a 6x, or the other way around, you get the same final answer, but I've gone 3x and 6x, so 3 terms to 4 terms. We then fully factorise the first 2 terms, so fully factorising 6x squared plus 3x, we get 3x open bracket 2x plus 1, and then we fully factorise the last 2 terms, which is plus 3, 2x plus 1. Now you may have to do a bit of jiggery-pokery with the sign here, the plus 3, to ensure that the second bracket equals the first bracket. So plus 3 ensures this. So we've got a 3x, 2x plus 1, a plus 3, 2x plus 1. And then our final answer comprises a pair of brackets, the first of which are the 2 bits that are not presently in a bracket, so the 3x plus 3, and the repeated bracket, the 2x plus 1. Now that's quite a manufactured process going downwards, but I think it makes more sense when you expand going the other way. So how do we expand a pair of brackets? Well, we take the 3x and we multiply that by both terms in the second bracket. That's what I've done here. And then you move on and take the 3 and multiply that with both terms in the second bracket. That's what I've done here. You then just expand the bracket, so it's actually doing this, so it's the 3x times the 2x, the 3x and the 1, the 3 times 2x and 3 and the 1 gives us this, and then of course our final bit would be to simplify, would be to gather together our like terms, giving us this. So the process makes a lot more sense expanding bottom to top than factorising top to bottom. Anyway, that's our final answer. So just like with any quadratic, when you solve to make it equal 0, you've got to consider the values of x which would make either bracket 0. So what value of x would make 3x plus 3 0? Well, that's minus 1, because obviously 3 lots of minus 1 is minus 3. Minus 3 over 3 is 0. How could we have done that more slowly? Well, we undo adding 3, we take away 3. To undo the timesing by 3, we divide by 3. So x is minus 1. Similarly, moving on to our second bracket, what value of x makes this bracket 0? Well, that is minus a half. Okay, so remember, 0 times whatever is 0, or whatever times 0 is 0. So our solution is just this.